Imaginary numbers are square roots of negative numbers. So since you, actually, specifically, I is supposed to be what number? It is a square root of negative 1. That's what I is defined to be, the square root of negative 1. So if I ask you to find the square root of negative 121, what do you tell me? The square root of 121 is 11, and then yes, you put an I on it. Well, turns out, now that we know how to break down a root with imaginary numbers, there's actually a cool pattern that happens when you start taking I to a power. And you're going to have to hang with me for a couple minutes till you can see the pattern coming at you. So we're going to start out, if I take I to the first power, what's anything to the first power? Itself. So I to the first power is I. Question is, what's I to the second power? Well, wouldn't that be I times I? Okay. And I is square root of negative 1. What do you get if you take a square root times itself? What was square root of 2 times square root of 2? 2. What's square root of 5 times square root of 5? 5. So what's square root of negative 1 times square root of negative 1? Negative 1. It's the number inside it. You got two of those. You can't make it positive. You can't go changing the sign. So I squared is really the same thing as negative 1. Okay. I'm not seeing much of a pattern yet. We've only done two numbers. Suppose I go to cubes. Would you agree I could say that's I squared times I to the first power? Because when you add those powers, you get 3. Okay. What's I squared? It's negative 1. I to the first power is just itself. So what's negative 1 times I? Negative I. So when you get to a cube, I cubed, you get negative I. Well, how's about I to the fourth? I'm still not seeing much. That would be a good choice. I squared times I squared. Yep. Which would be negative 1 times negative 1. And so now you get, there's your positive 1. So I to the fourth is always positive 1. Well, you think, can this keep going? If I go to I to the fifth, will I get something different again? The easiest way is if I take the I to the fourth I just did, times I to the first, because what's I to the fourth? I to the fourth is 1. So 1 times I is going to be, it's just going to stay I. Yeah, so then when I do I to the sixth, I'm going to do I to the fourth times I squared. Well, since I'm always going to get 1, I'm just going to get what I squared is. And I squared is negative 1, so I'm just going to get negative 1, so it's just going to start repeating itself. After the first 4, it just repeats over and over and over. So all you ever have to know are the first 4 powers of I, and you can figure out any power of I. So I'm going to rewrite that nice and neat, though, so you can see it. This will, by the way, be the first question on the quest. Fill in the powers of I. Now, I don't know if this is a great saying for remembering this, but this is the saying they came up with. Somebody knows, hey, look, it goes an I, then a 1, an I, then a 1. So oh, look, it's I won. Like, I won, you know, the prize, I won. So, it's I won, with 2 negatives in the middle. It's not great, but it works. They remember it. So, that's your powers of I. I won with 2 negatives in the middle. That's what you want to keep going. But then, now that you know that, you can now figure out any power of I you ever wanted to take it to a power. Notice, when you get done with these, do you ever end up with a power on any of these answers? No. So if you're ever working problems with I's, you should never have a final answer that has I with a power on it, because you can always simplify it using one of these. So I may say to you, hey, find me I to the 14th power. Okay, well, this one's fairly small. I just saw what Daisy did. She did it on her fingers. This is what I'm going to do. I could go, well, there's 1, 2, 3, 4. Then I'd have 5, 6, 7, 8, 9, 10, 11, 12. 13, 14 would land on the -1. It's the same thing as I to the second. Okay, and it ends up being -1. There's got to be a better way, though, because if I give you I to the 5,368th power, I don't think you're going to count that out. So what's a better way? What I want you to notice, it ended up being the same thing as I squared. What did 2 have to do with this? We had 14. You're actually, because what would be a shortcut? I know it has to, I have 4 powers, so what should I actually do to 14? Yeah, you would do 14 divided by 4, which goes in there 3 times. But the key thing is your remainder is 2. Because what's the 3? It goes through this cycle of 4 things 3 times, and then you've got 2 left over, so it ends up being the same thing as I squared. So what you're after is what's the remainder when you divide it by 4. Don't care how many times it goes in, we want the remainder when we divide it by 4. So let's try a little bigger power. Suppose I said, okay, let's do I to the 75th power. You really want to sit there, you don't want to sit there and count it. I don't know that you want to do 75 divided by 4 by hand either, for that matter. But if you put it in your calculator, what does it tell you? $18.75. Well, okay, which part of that's the remainder? The 0.75. So it's the 0.75 that matters. Well, how do I use 0.75 to figure out which power of I this is? Bingo. 0.75 is the same thing as the fraction 3/4. So therefore, it's the same thing as I cubed. So if you divide it on your calculator by 4, if you get something with a 0.75, you know you're on I cubed. What's it going to be if you're on I squared? 0.5, because 2/4 would be 0.5. And if you're on I to the first, it's going to be something 0.25. What's it going to be when you're on I to the 4th? It'll be a whole number, because when you divide by 4, if it comes out evenly, then you can't get a remainder of 4. So it's got to be essentially 0.00 if you want to think of it that way. You get no decimal left. If it divides evenly by 4, you're on I to the 4th. So you can actually figure them out fairly quickly. So now tell me, I to the 75th then came out to be 3/4, so we would go, oh, that's negative I. Let's go hog wild crazy. Suppose I want you to do the 6,700 and what would be good? 6,773. What power of I is that? What would you do? You would divide it by 4, and you would look for the decimal you got. So what decimal do you get? Yeah, you get something, some number, 0.25. 0.25 is 1/4. So therefore you are I to the first. So it's just I. Now, you're going to have some problems that do that. And then I go give you one like this, and I have people start breaking the rules of algebra. If I give you something like this, 3 times I to the 34th power minus 2 times I to the 65th power plus I to the 203rd power, would it be legal for me to just add up all those powers of I and get I to some power? Can you add x squared plus x cubed? It's not a like term, so you can't add i's either. So you have to figure out each one of these first and then simplify it down, if it will. So the 3 out front you would leave sitting there. How would you get I to the 34th? 34 divided by 4. Or actually, guys, that's a small one. You can divide it by 4. It goes in there times 8, it goes in there to 32. So what's the remainder? 2. 32 to 34. So yeah, if you're on I squared, you're at negative 1. And 65, actually, if you think about it, 64, 4 goes into 64 evenly, so that means you're going to have a remainder of what? 1. If you divide it, you'll get 0.25. So you get I to the first. Yeah, you did it just I. And then actually, 203. If you're on even hundreds or thousands, doesn't 4 divide into them evenly? Yeah. So if you're on hundreds or thousands, that means the remainder is 3. Which means it's a I cubed is negative I. Then you go add together. So that's really a negative 3, a negative 2i, plus a negative I. Add your like terms. What can you combine? You can add the i's. So you have negative 3 minus negative 2i plus negative 1 would be negative 3i. It's just like adding x's. Negative 2x plus a negative x is negative 3x. And there would be your solution. It's kind of weird. And yes, it's like, why would anybody care? Why would somebody use the i's? If we have time, I'm going to show you some, well, one of those. I don't know the details because I haven't taken electrical engineering courses, but they represent different characteristics of electricity with imaginary numbers. So I know people who do anything with electricity, and particularly electrical engineers, get to do lots of stuff with eyes. So, is that what Zach's in? So see, ask him about it. What's he do with his imaginary?
I don't really like to talk about it because it depresses him.
It depresses him? Why?
He said that if he could do it over, he wanted to do electrical engineering because it was that hard.
Don't know that it's any harder than any of the others. Okay, a little more imaginary before we go complex. This is yesterday's assignment with one extra step. I want to take negative square root of 6 times negative square root of 32. Okay, you can multiply them, but there's one little problem when they have the negatives in them. If I multiply them right now, I take negative 6 times negative 32, won't I get a positive number? Yeah, and you'll come out wrong. The one stipulation you have if you're dealing with negative roots, before you can multiply it, you have to take the negative out and make it an I, or it won't work right. So I would have to pull the negative out and say that's I times the square root of 6, because you'll see why in a moment. Now, the 32, you want to break it down, or you want to wait till later? I would do it now. Smaller numbers are easier. So what breaks 32? It's a fairly big number. 16, yeah, 16 times 2. So when I take the 16 out, I get 4i square root of 2. Now, you just have to do all the multiplying and simplifying. So when I multiply, what will I get? 4, what's I times I? I squared, okay, and then square root of 6 times square root of 2, that'd be square root of 12. So now you'll notice you go, whoa, I can never have I with the power in my answer. So therefore, what should I change I squared into? If you look at your list of powers of I, yeah, I squared is -1. That's the one you're going to use by far the most. I squared is the one we see way more than any others. Okay, is 12 square root of 12 simple? Yep, 2 square root of 3. And then, what can I multiply together? Yeah, 4, -1, and 2. Anything not in the root can get multiplied. So that would give me -8 square root of 3. Notice you came out with a negative answer. If you had multiplied this together first, you would have made it positive. You'd have never gotten the negative answer. And that's because of the I's. So. This other one is the exact same thing as what you just did on your last assignment, except there might be an I involved. If I say solve for x, same thing we did yesterday, I solve for x. Yeah, normal solving. Subtract 65 would give me a -54. Then what? Divide by 3 would give me a -18. Square root it. And then what do you have to remember to do when you've square rooted both sides? Plus or minus. So it's going to be plus or minus, but I got to break that baby down. 9 and 2. So it'll be a 3. And take out the negative. That'll be an I square root 2. And that would be your solution. Is that a big deal? Okay, that's good. Whoa. Ooh, over.